In question 5, we want to find out the domain of our inverse function. So we want to find out the domain of the inverse function. Now, because the function is literally an inverse of the previous one, of f of x, that means that the domain corresponds to the range of f of x. So if you can find out the range of f of x, we will know our answer. So how can we find out the range of our original function? The range of f of x. Well, we have to give values. We have to see what values does this function approach. Now, in the question is given that x has to be greater than 0. Alright, so if x is greater than 0, if x is just a bit greater than 0, what would be the case? Let's say when x approaches 0, let's call it like that. X approaches 0. X approaches 0. Well, let's not think about the 4 at the moment, because 4 will be just a constant that is multiplied with what's happening in the logarithm. Let's see what's happening in the logarithm, because that's the most interesting part. Remember, we have ln of square root of x plus 4 minus 2. Alright, now x is slightly greater than 0. So if x is slightly greater than 0, what happens in our logarithm? Well, we would have square root of 4 plus, let's say, 0.01. Let's say over here we would have square root of 4 plus 0.01. Well, square root of 4.01, that's slightly higher than 2, but not by much, right? Because square root of 4 is 2, then square root of 4.0 something is going to be slightly higher than 2. Now, this is just a bit higher than 2. Something a bit higher than 2, and we subtract minus 2 from here. Well, the whole result of this bracket is going to be a decimal, is going to be 0.0 something. So 0.0 something. I hope this makes sense. Once again, just to make sure we get it. This thing is square root of a number bigger than 4. A number bigger than 4, as a result, under square root, will have a number slightly bigger than 2. Deduct from that the 2, we're left with the difference, and the difference is a decimal. Now, what happens when we have the logarithm of a decimal? And I encourage you to take your calculator out and write down ln of a decimal. Let's say ln of 0.001. Well, if you put it in the calculator, you will see that the result is negative. And if you put a number which is even more, even smaller, 0.00001, that's even more negative. So the idea here is that as the input in our logarithm becomes smaller and smaller, our result of ln of what we have inside tends to negative infinity. So the smaller the difference between the values, the more negative the result. Now multiply that by 4 is just gonna make the result even more negative, because a negative number times 4 is even more negative. Let's say minus 3 times 4 becomes minus 12. That's even more negative. Let's say minus 3 times 4, that's equal to minus 12. That's even more negative. It's further away on the negative axis. So that was the whole point of putting values which are slightly higher than 0, to see that the result actually becomes very, very negative. And what would happen if we have x being very large? What would happen if we have x being very large? Let's say if x approaches infinity. So if x approaches infinity, let's write over here, if x approaches infinity, well, we would have ln of square root of x plus 4 minus 2. Well, if this thing approaches infinity, we would have the square root of a very large number, and this number will also be very big. So x would be large. It wouldn't be a decimal. It would be something as a very large number. Let's say if you would have x equals to 100. Well, square root of 104, that's gonna be much larger than 10. I mean, slightly larger than 10. 10 minus 2 is 8. ln of 8, well, that would be a positive number, because ln of positive numbers is also positive. I'm sorry, ln of numbers when we have ln of x and we know that x is greater than 1, then the ln of x in that case would be positive. And in our case, because x would be a large number, we would have a logarithm that's very positive. So the result, the larger the x here, the larger the logarithm. The result will approach positive infinity. Now, to sum up, what did we do? As x approaches 0, we can see that our result tends to negative infinity. As x approaches infinity, our result also tends to infinity. So that means that the range of our function of f of x literally ranges from negative infinity to positive infinity, and that's also the domain of our inverse. And that's it. That's the answer.